Welcome back. Today I will resume my previous talk about the desert. We will talk about the human relationship with the desert. How did the water form in the desert? Let's go. Water. One of the driest places on Earth is the Atacama Desert. It is virtually devoid of life, because it is blocked from receiving precipitation by the Andes Mountains to the east and the Chilean coast range to the west. The cold Humboldt Current and the anticyclone of the Pacific are essential to keep the dry climate of the Atacama. The average precipitation in the Chilean region of Antofagasta is just 1 mm (0.039 in) per year. Some weather stations in the Atacama have never received rain. Evidence suggests that the Atacama may not have had any significant rainfall from 1570 to 1971. It is so arid that mountains that reach as high as 6,885 meters (22,589 feet) are completely free of glaciers and, in the southern part from 25 degrees S to 27 degrees S, may have been glacier-free throughout the Quaternary, though permafrost extends down to an altitude of 4,400 meters (14,400 feet) and is continuous above 5,600 meters (18,400 feet). Nevertheless, there is some plant life in the Atacama, in the form of specialist plants that obtain moisture from dew and the fogs that blow in from the Pacific. When rain falls in deserts, as it occasionally does, it is often with great violence. The desert surface is evidence of this, with dry stream channels known as arroyos or huaytas meandering across its surface. These can experience flash floods, becoming raging torrents with surprising rapidity after a storm that may be many kilometers away. Most deserts are in basins with no drainage to the sea, but some are crossed by exotic rivers sourced in mountain ranges or other high rainfall areas beyond their borders. The River Nile, the Colorado River, and the Yellow River do this, losing much of their water through evaporation as they pass through the desert and raising groundwater levels nearby. There may also be underground sources of water in deserts in the form of springs, aquifers, underground rivers or lakes. Where these lie close to the surface, wells can be dug and oases may form where plant and animal life can flourish. The Nubian sandstone aquifer system under the Sahara Desert is the largest known accumulation of fossil water. The Great Man-Mad River is a scheme launched by Libya's Muammar Gaddafi to tap this aquifer and supply water to coastal cities. Karga Oasis in Egypt is 150 kilometers (93 miles) long and is the largest oasis in the Libyan desert. A lake occupied this depression in ancient times, and thick deposits of sandy clay resulted. Wells are dug to extract water from the porous sandstone that lies underneath. Seepages may occur in the walls of canyons, and pools may survive in deep shade near the dried-up watercourse below. Lakes may form in basins where there is sufficient precipitation or meltwater from glaciers above. They are usually shallow and saline, and wind blowing over their surface can cause stress, moving the water over nearby low-lying areas. When the lakes dry up, they leave a crust or hardpan behind. This area of deposited clay, silt or sand is known as a playa. The deserts of North America have more than 100 playas, many of them relics of Lake Bonneville, which covered parts of Utah, Nevada and Idaho during the last ice age when the climate was colder and wetter. These include the Great Salt Lake, Utah Lake, Sevier Lake and many dry lake beds. The smooth flat surfaces of playas have been used for attempted vehicle speed records at Black Rock Desert and Bonneville Speedway, and the United States Air Force uses Rogers Dry Lake in the Mojave Desert as runways for aircraft and the Space Shuttle. People have been living in deserts for millennia. Many, such as the Bushmen in the Kalahari, the Aborigines in Australia, and various tribes of North American Indians, were originally hunter-gatherers. They developed skills in the manufacture and use of weapons, animal tracking, finding water, foraging for edible plants, and using the things they found in their natural environment to supply their everyday needs. Their self-sufficient skills and knowledge were passed down through the generations by word of mouth. Other cultures developed a nomadic way of life as herders of sheep, goats, cattle, camels, yaks, llamas or reindeer. They traveled over large areas with their herds, moving to new pastures as seasonal and erratic rainfall encouraged new plant growth. They took with them their tents made of cloth or skins draped over poles, and their diet included milk, blood, and sometimes meat. The desert nomads were also traders. The Sahara is a very large expanse of land stretching from the Atlantic Rim to Egypt. Trade routes were developed linking the Sahel in the south with the fertile Mediterranean region to the north, and large numbers of camels were used to carry valuable goods across the desert interior. The Tuareg were traders, and the goods transported traditionally included slaves, ivory and gold going northwards and salt going southwards. Berbers with knowledge of the region were employed to guide the caravans between the various oases and wells. Several million slaves may have been taken northwards across the Sahara between the 8th and 18th centuries. Traditional means of overland transport declined with the advent of motor vehicles, shipping and air freight, but caravans still travel along routes between Agadez and Bilma and between Timbuktu and Taoudani, carrying salt from the interior to desert-edge communities. Round the rims of deserts, where more precipitation occurred and conditions were more suitable, some groups took to cultivating crops. This may have happened when drought caused the death of herd animals, forcing herdsmen to turn to cultivation. With few inputs, they were at the mercy of the weather and may have lived at bare subsistence level. The land they cultivated reduced the area available to nomadic herders, causing disputes over land. The semi-arid fringes of the desert have fragile soils which are at risk of erosion when exposed, as happened in the American Dust Bowl in the 1930s. The grasses that held the soil in place were plowed under, and a series of dry years caused crop failures, while enormous dust storms blew the topsoil away. 500,000 Americans were forced to leave their land in this catastrophe. Similar damage is being done today to the semi-arid areas that rim deserts, and about 12 million hectares of land are being turned to desert each year. Desertification is caused by such factors as drought, climatic shifts, tillage for agriculture, overgrazing and deforestation. Vegetation plays a major role in determining the composition of the soil. In many environments, the rate of erosion and runoff increases dramatically with reduced vegetation cover. Deserts on other planets. Mars is the only other planet in the solar system besides Earth on which deserts have been identified. Despite its low surface atmospheric pressure, only 1/100th of that of Earth, the patterns of atmospheric circulation on Mars have formed the sea of circumpolar sand more than 5 million square kilometers, 1.9 million square miles, in the area, larger than most deserts on Earth. The Martian deserts principally consist of dunes in the form of half-moons and flat areas near the permanent polar ice caps in the north of the planet. The smaller dune fields occupy the bottom of many of the craters situated in the Martian polar regions. Examination of the surface of rocks by laser beam from the Mars Exploration Rover have shown a surface film that resembles the desert varnish found on Earth, although it might just be surface dust. The surface of Titan, a moon of Saturn, also has a desert-like surface with dune seas.